Productivity versus performance. This is a big one. As an industry, if I ask people for a long time, is performance your highest priority? They would say yes. But the reality is that productivity has been our highest priority. It has been in just the languages we've been designing, the languages we've been using. People want to be productive and get things done. And we've kind of looked at performance as secondary, though if you ask anybody, they're too afraid to tell you that, because then you don't look like you're technical or your chops are in place. We put people on a pedestal who can get on stage and talk about how they can shave a few milliseconds or microseconds off of an algorithm. And I really kind of want to move away from that. Productivity really is and should be our highest priority, but we do need performance. It does matter. And what I find interesting about our industry is that for the last 30 years, we have kind of been on the same path that Nicholas Wirth has said back in 1987. He said that the hope is that the progress in the hardware is going to cure our software ills. In other words, he's saying that we as software developers have always said, we don't have to worry about performance. The hardware will come in and save us. And we've continued to kind of have this mantra for the last 30 years. Back in 1987, after I graduated high school, I was on a plane to Italy, and I sat next to a software developer, and that software developer told me, this is 1987, that all of us right now watching this video would be BASIC developers. We'd all be coding in BASIC today because the hardware would be so fast, we wouldn't need anything else. The reality is that has not happened. I mean, Henry back in 2015 wrote, the most amazing achievement of the computer software industry is this continuing cancellation of the steady and staggering gains made by the computer hardware industry. We're still talking about this stuff 30 years ago. Remember, I told you before, the hardware is the platform. If performance matters, then we have to be sympathetic with the hardware, mechanical sympathies. And look, the hardware folks really haven't changed hardware in the last 15 plus years. They really haven't. We've had these multi-core processors, multiple hardware threads per core, and the reason why they're not doing it is because we haven't been able to take full advantage of what's there now. We're starting to see now Intel talk about their 24, 36 core processors. And that's great and it sounds amazing, but if we don't engineer for this hardware, if we don't understand how it works, those processors are actually going to slow us down, not speed us up. So we're going to spend some time in this class talking about how caching works and some of the mechanical sympathies the language drives through us and allows us so we can get to these levels of performance and we want, and hopefully take advantage of the hardware that's there so the hardware industry stops playing games and starts giving us more. But that's on us, it's not on them. But I think a core part of this class is going to be this next quote from Brian Kernighan. And it starts him talking about C. He was asked a question about the C programming language, but I think you can replace C with Go, and it absolutely mirrors it exactly. Go is the best balance I've seen between power and expressiveness. You can do almost anything you want to do by programming fairly straightforwardly and have a good mental model of what's going to happen on the machine, and you can predict reasonably well and how quickly it's going to run and understand what's going on. This is Go in a nutshell. I'm going to teach you how to read code in this language, so that holds true not just for me, but for you. And it's possible because Go's model is not a virtual machine. It is a real machine. It is the real machine. And once you're coding against the real machine, then you can do all of these things if you just know a little bit about the mechanics and the semantics of the language. When I say mechanics, I'm talking about how things work. When I say semantics, I'm talking about how things behave. And I'm going to teach you throughout this class how to be able to do that, and that's going to drive you being able to make some better engineering choices.